All right, let's talk about the hidden code that pretty much powers your entire world. It's this invisible force, right? Running on billions of devices, from your phone to the cloud, and I'd bet you've used it in the last hour without even knowing. We're talking about Java. So to really get a feel for how big this thing is, let me ask you a question. Think about the apps on your Android phone, or those gigantic servers that run companies like Netflix. And what about the global financial systems moving trillions of dollars around every single day? What's the one piece of tech that connects all of them?
And the answer? Well, it might just surprise you. It's a programming language that was born back in the 90s. Yep, they are all in some really fundamental way built on Java. Its DNA is just woven into our digital world, making it one of the most important technologies ever created. Seriously.
To understand why Java took over the world, we have to go back in time. Back to when making software was, well, it was messy, it was super frustrating, and it was unbelievably expensive.
See, before Java came along, software was basically trapped. Imagine you spend months, maybe years, building an amazing application, only to find out you have to start all over again for every different kind of computer. A program you wrote for Windows was totally useless on a Mac. And this wasn't just a headache, It was a business nightmare. It just killed growth and innovation.
And this is where Java just completely changed the game. It came in with this simple but absolutely revolutionary promise. Write once, run anywhere. All of a sudden, you could create one single version of your software, and it would just work. It didn't matter if it was on a Mac, a Windows PC, or some Linux server in a data center. This wasn't just a cool tech trick. It was a fire starter for business on a historic scale.
Okay, but that promise, it sounds a little bit like magic, right? How can one piece of code speak the language of so many different machines? Well, it's not magic. It's actually a really, really brilliant piece of engineering.
So let's break it down. We're going to follow a piece of Java code on its journey, all the way from the developer's keyboard to your screen. It all happens in three main steps. You write the code, you compile it into this universal format, and then you run it through a special translator.
So it all starts with the developer, right? They're typing away, writing out all the instructions in a plain old text file. This is the source code. It's human readable. It's the blueprint for what the application is supposed to do.
Okay, you've got your code. The next step is to feed that blueprint into something called the Java compiler. Now, the compiler's job is to translate the code, but here's the crucial part. It doesn't translate it into the specific language that a Windows or a Mac computer understands directly. Instead, it creates something really special, bytecode. The best way to think about bytecode is like a universal recipe. A recipe that any chef in any kitchen, anywhere in the world can follow. It isn't written for one specific oven. It's a generic set of instructions. And that right there is the key to all of its power.
So you've got this universal recipe, this bytecode. How does your computer actually, cook it? Well, that's where the secret sauce comes in, the Java Virtual Machine, or the JVM. The JVM is that universal translator living inside your computer. Its only job is to take that universal bytecode recipe and translate it on the fly into the exact actions your specific machine needs to perform.
So check this out. That one bytecode file can be sent to a Windows computer, and its JVM translates it perfectly for Windows. Then you take that exact same file, no changes, and send it over to a Mac, and its JVM translates it perfectly for Mac OS. That is write once, run anywhere in action. This single idea just blew the doors open for software to reach everybody, no matter what device they were using.
But, being able to run anywhere was just the start. That was the hook. To really get why Java has stuck around for so long, we got to look at the other features that made it so incredibly reliable and secure, basically cementing its place in the Software Hall of Fame.
Java was basically built like a fortress. First off, it's super secure, with all these layers of defense to stop bad code. It's also incredibly robust, which is just a fancy way of saying it's really, really stable. And it's object-oriented. Now that sounds complicated, but just think of it like Legos. Instead of one giant messy sculpture, you build with small, reusable bricks of code that all snap together. It lets you build huge, complex things that are still well organized.
And this table here? It really drives the point home, especially when you compare it to older languages like C++. With C++, developers had to manage the computer's memory by hand. It was like being a juggler with 100 balls in the air. If you made one little mistake, the whole thing came crashing down. Java fixed this with its garbage collector, which you can see right there. It just automatically cleans up after itself, making programs way safer and so much easier to write. It's easy to think of Java as this thing from the 90s, but its story absolutely did not end there. A huge reason for its incredible staying power isn't just how it started, but the fact that it has been constantly, relentlessly evolving.
So it all kicked off back in '91 as this secret project called Green. But then, bam! 1995, it goes public, right as the World Wide Web is exploding. I mean, perfect timing, right? But it didn't just stop there. In 2014, Java 8 came out, which was this huge modernization that gave it all sorts of new powers. And it's still going. With major new versions like Java 21 coming out just recently, it's proving it's still a top-tier, cutting-edge tool for developers today. So, when you boil it all down, what was Java's real revolution? It was about breaking down walls. It made software independent from the machine it runs on, and in doing so, it created a universal language that let developers build the digital world that we all live in today.
And that leaves us with a really fascinating question for today. Java solved the problem of portability for computers. But now, as we're moving into this new era of AI, of the cloud, what's going to be the next write once, run anywhere? The next massive leap is out there, just waiting to be discovered. And who knows? It might just be inspired by the very same ideas that made Java so revolutionary in the first place.